Okay guys, chapter 2, section 1 for trig. So this whole time in chapter 1, we were talking about the different ratios, sines y over r, cosines x over r, tangents y over x. That whole time, we were technically doing SOHCAHTOA. So some old hippie caught another hippie tripping on acid, as I like to say. But this is technically telling you sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So sine is O over H, opposite over hypotenuse. Cosine is A over H, adjacent over hypotenuse. And tangent is opposite over adjacent. Cosecant, we're just going to flip. It's the hypotenuse over the opposite side. Secant, hypotenuse over the adjacent side. And cotangent, adjacent over the opposite side. So looking at example 1. In example 1, we need to find the sine, cosine, and tangent values for angles A and B in the right triangle. So we have a right triangle. Its sides are 7, 24, and 25. So looking at angle A, we're going to do this one in green. Angle A, the sine of A is going to be its opposite side. You always have to travel across the triangle to get to the opposite side. So opposite side is 7. And the hypotenuse is always the side across from the right triangle. So that is 25. So even if you want to label them, 7 is your opposite, 25 is your hypotenuse, and 24 is your adjacent. So the cosine of A is the adjacent over the hypotenuse. So 24, this adjacent side touches this angle. That's why it's adjacent to it. So 24 is going to be my adjacent side. 25 is still my hypotenuse, so 24 over 25. Same thing again, looking at angle A, my opposite side is 7. My adjacent side is 24. So opposite over adjacent, 7 over 24. Now if you look at angle B, so we're going to do that in red. Angle B, 24, is my opposite side. 7 is my adjacent side. And my hypotenuse still stays the same. So looking at angle B, my sine is going to be my opposite over my hypotenuse. So it'll be 24 over 25. Cosine will be my adjacent over my hypotenuse, so 7 over 25. And then tangent's going to be opposite over adjacent, so 24 over 7. So now what looks similar? If we look at this, the sine of B is the same value as the cosine of A. And the cosine of B is the same value of the sine of A. So these are co-functions of each other. So if we have a little triangle that I forgot to add in, we have a little right triangle, and we have sides A, B, or AC, and B. And we have angles B, A, and C. Looking at this little triangle, co-functions are trig functions that have the same values. So sine and cosine are co-functions of each other. Okay, so sine, if you look at the sine of A, is A over C, and the cosine of B is A over C. Tangent, opposite over adjacent. So the tangent of A is going to be A over B. But then you see that it's paired up with its reciprocal. It's paired up with the cotangent of B. So up here, cotangent's adjacent over opposite. So tangent of A is opposite over adjacent, so A over B. And then the cotangent of B is going to be the adjacent over the opposite, so it's going to be A over B. And then you see secant is paired up with its opposite reciprocal. So secant, since sine and cosine are cofunctions, their reciprocals are cofunctions. So the secant of A, secant's going to be hypotenuse over adjacent. That's going to be C over B. And the cosecant is going to be the hypotenuse over the opposite. So if you're looking at the cosecant of B, it'd be C over B. So those are the three cofunctions within the trig functions. There is a cofunction identity chart on page 49 of your book. That's something important to look at. So cofunctions, since they are cofunctions, they add up to 90 degrees. They're kind of like coterminal angles. So when it comes to finding or writing in terms of cofunctions, you got to use those little identities that are on page 49. So the cosine of 52. Well, I know cosine and sine are cofunctions of each other. So the identity is the cosine of 52 degrees is going to equal the sine of 90 minus 52. And when we do that, we're going to take 90 minus 52, and that's going to give me the sine of 38. So the cosine of 52 and the sine of 38 have the same values. They're the same, they add up to 90 degrees. They're the same angle. They have the same values for each of them. If we look at the tangent of 71, tangent and cotangent go together. So I'm going to say the tangent of 71 degrees equals the cotangent of 90 minus 71, which is then going to equal the cotangent of 19 degrees. So the tangent of 71 and the cotangent of 19 are the same. Okay. Example 3. Solving equations using cofunctions. So since you see up here we subtracted from 90, since they are complementary to each other, cosine and sine are cofunctions. So since these are cofunctions, we can add them together and set them equal to 90. So the cosine and the sine, you're going to completely ignore. You're just going to take what's in the parentheses. I'm going to say theta plus 4 plus 3 theta plus 2. And I'm going to set that equal to 90 degrees. So we're going to solve this equation. Theta works just like x, so theta plus 3 theta is 4 theta. 4 plus 2 is 6, and that's going to equal 90 degrees. I'm going to subtract 6 from both sides. 4 theta is going to equal 84 degrees. And I'm going to divide both sides by 4. And I'm going to get theta to equal 21 degrees. So just solve a simple equation, pull what's out of the parentheses, add them together, set it equal to 90 degrees. That's example 3. Example 4, we want to determine whether each statement is true or false. So every year I say just look at these. The sine of 21, they want to know if it's greater than the sine of 18. Just look at the numbers. Is 21 greater than 18? Yes, it is, so this is true. Over here, secant of 56 degrees is less than or equal to the secant of 49 degrees. Again, look at the numbers. Is 56 less than or equal to 49 degrees? No, it's greater than, so that is false. We have special right triangles. This should be a review. Special right triangles, you have your 30, 60, 90 triangle, and your side values are 1, 2, and the square root of 3. And then in your 45, 45, 90 triangle, your side value, your legs are 1, and your hypotenuse is the square root of 2. So using these triangles, we want to find the trig values of 60 degrees. So we have the special right triangle. We're going to focus in on the 60 degrees. And using what we learned with SOHCAHTOA, we're going to fill these in. So the sine of 60, opposite over hypotenuse. So that's the square root of 3 over 2. The cosine, adjacent over hypotenuse, is 1/2. The tangent, opposite over adjacent, is just going to be the square root of 3. And then to flip them, cosecant will be 2 over the square root of 3. Remember to rationalize, so that's 2 square roots of 3 over 3 as your answer. Secant is just going to be 2. And then cotangent, we technically have 1 over the square root of 3, which would then be the square root of 3 over 3. Now, there are 3 angles that by the time you're done with trig, you should be able to name these off the top of your head. And that should happen for 3 angles. That should be 30, 45, and 60. Those are your main angles that we're going to refer to throughout this whole process. So in your book on page 52, I would suggest writing down the little table, the function values, special angles. Function values. I would write that down. And with that, that is chapter 2, section 1. Your homework is posted on the agenda. Be sure to take notes with this video. If you have any questions, let me know.